Okay, this final example here is going to go ahead, and the one that's in blue has some stuff going on it. We're going to use the zero product property to knock this thing out. And why we have to use the zero product property is that we notice that we have cotangent on both sides of the equation. And many students make this mistake by saying, I'm going to divide through by cotangent x. However, that would be incorrect because you end up losing answers. You don't want a variable to completely go away and just be left with cosine squared x equals, in this case, 2. So that would be incorrect. What we do want to do is that we want to move everything to one side. So I'm going to choose to go ahead and move all the cotangent stuff to the left-hand side here, like that. And I'm going to start way back up here to give us some room. And this is going to give us the cotangent of x times the cosine squared of x minus 2 cotangent x equals 0. So now what I need to do is that I need to factor out that part right there so I can have a product of two things equal to 0, so I can apply the zero product property. So this is going to give me cotangent x times whatever's left over, cosine squared x minus 2. So again, I'm taking this and I'm factoring it out in front right there, right? So that guy is going to come out in front and be right here. So now the trick is that we got these equal to 0, so I can set both of these equal to 0 and start to go ahead and craft my answer from there. So, oops, forgot to set that equal to 0. So now that they're both equal to 0, and these are, even though I put them kind of close to one another, this is going to be that guy right there, and then this is this guy right here. Okay, so I want to solve both these out. So now I have to think, okay, for cotangent, I want to find all the instances in which that's going to go ahead and be 0. So one of the ways that we can think about is, well, we know that cotangent at basically at 0 degrees is going to be undefined, and you might want to go ahead and sometimes think about the graph when we have tangent and cotangent. And if you look, right, it starts undefined at 0, and in its parent form at pi, it goes back to undefined. So we got undefined at 0, the asymptote, and then we have undefined at pi. So it's going to go ahead and make sense that the angle that is going to give cotangent, make cotangent go to 0 is going to be right in between those two, and that's going to be pi over 2. So this guy right here. And we know that this is going to give us the undefined and the undefined for cotangent, and it's going to repeat itself, so we'd go pi over 2, and then it's going to repeat itself again when we come back down here and go 3 pi over 2. So it looks like every half turn around the circle, it's going to give us another solution. So what we would say is x equals pi over 2 plus pi n, where n is an integer. Is an integer for that part of the solution, and that itself would be one part. So now we have to analyze this second part right here. And so what we want to do is that we want to start working this thing out, and we would have cosine x equals cosine squared x equals 2. We'd take the square root of both sides, and we would get the cosine of x equals plus or minus the square root of 2. Now, in this case, we know that there's no angle that we could plug in for x that is going to give us the square root of 2. it's going to give us a square root of 2 over 2, but that's not what we're looking for. And therefore, the square root of 2 is going to be out of our cosine's range, and therefore we would have no solution for this part. Now, it's only for that part. So that means is that this, to put the pieces together, is just nonsensical, because I can't go ahead and get the solution for this. So the only solution that I'm worried about, and the final solution, would be this guy right here. X equals pi over 2 plus pi n, where n is an integer, simply because the cotangent x equals 0 is the only part of this product right here that happens to have a solution. So that's how you do that, and thank you for watching.